The growing controversy surrounding NASA's handling of the high-rise images of the interstellar object 3I/Atlas has intensified in recent weeks, especially after Harvard astrophysicist Avi Loeb publicly accused the agency of withholding information that he believes could be crucial for understanding one of the most mysterious space objects ever observed. Loeb has been vocal about what he describes as an unnecessary delay, even calling it a bureaucratic obstacle that is slowing down scientific progress at a time when rapid analysis is essential. According to him, NASA possesses exceptionally detailed photographs captured by the high-rise camera aboard the Mars Reconnaissance Orbiter during 3I/Atlas's close approach to Mars on October 2, 2025. These images, he insists, hold key data that could help researchers uncover the object's true nature, yet they remain inaccessible to the public and scientific community. Despite his repeated requests, the agency has not released them, and NASA's justification that the ongoing U.S. government shutdown has disrupted operations has only fueled his frustration and suspicion. Loeb argues that invoking the shutdown is a convenient excuse rather than a legitimate reason. While government shutdowns indeed affect federal agencies and limit certain operations, he believes that releasing scientific data, especially data that is already captured and stored, does not require the level of governmental involvement that NASA is suggesting. In his view, the delay has less to do with logistical complications and more to do with internal caution, risk management, or perhaps reluctance to publish images that may raise more questions than answers. Loeb has repeatedly stated that transparency should come first, especially when dealing with an interstellar object, something profoundly rare and scientifically significant. The implication that NASA might be sitting on the highest resolution images ever taken of 3I/Atlas, while researchers around the world eagerly await more details, has created widespread debate among astronomers, enthusiasts, and the general public. To Loeb, the issue isn't merely about access to pictures. It is about the broader scientific process. He emphasizes that high-resolution high-rise imagery, which can far exceed the detail provided by the Hubble Space Telescope, could allow experts to confidently determine the physical characteristics of 3I/Atlas. These include the size, shape, texture, rotation dynamics, and even the composition clues hidden in surface reflectivity and structural patterns on the object. But perhaps even more intriguing is the unusual and puzzling anti-tail structure that 3I/Atlas displays. Unlike typical comet tails, which stream away from the sun due to solar radiation pressure and outgassing, an anti-tail points in the opposite direction and is usually only a matter of perspective. However, astronomers observing 3I/Atlas have noted that its orientation is stranger than usual, suggesting some kind of atypical dust distribution or a geometric configuration that challenges conventional comet behavior theories. Loeb believes that the withheld images may help explain this anomaly, enhancing our understanding of whether 3I/Atlas behaves like a conventional comet, a fragmented interstellar body, or something else entirely. For scientists, time is a critical factor in studying interstellar objects. Their trajectories take them through our solar system only once, often for a brief period, and missing the chance to collect and analyze data in real time could lead to permanent gaps in scientific knowledge. Loeb argues that allowing a bureaucratic process to interfere with timely access to these images undermines scientific priorities. The longer the delay, the harder it becomes for astronomers to coordinate follow-up observations, adjust theoretical models, or validate hypotheses about the object's composition and origin. The scientific community thrives on rapid sharing of information so that multiple teams across the world can collaborate, compare findings, and reach well-supported conclusions. By withholding essential data during a critical observation period, Loeb believes NASA is inadvertently hindering global scientific efforts. His critique takes on a deeper significance when one considers Loeb's previous statements and research on interstellar objects. He has long argued that objects entering our solar system from interstellar space could be natural or, in rare cases, potentially artificial in origin. While he is not claiming that 3I/Atlas is artificial, He maintains that such possibilities can only be properly evaluated if agencies provide complete transparency. He fears that any unnecessary control over data, especially high-quality data, could lead to decades of speculation, misinformation, or missed scientific breakthroughs. Loeb stresses that withholding information, intentionally or not, tends to amplify suspicion rather than reduce it, especially among a public already skeptical about government institutions and their willingness to share scientific discoveries without filters. As the government shutdown stretches on 43 days at the time of Loeb's comments, NASA has referenced operational limitations as a key factor in the delay. Shutdowns can hamper communication, staffing, administrative approvals, and coordination between departments, but many scientists agree that image release processes, especially for already captured images stored on NASA servers, should not require extensive manpower or political oversight. The situation has therefore created an emotional and intellectual split. Some agree with Loeb, seeing the delay as scientifically harmful, while others urge patience and trust in NASA's internal processes. Still, the tension between urgency and caution has made this controversy one of the most discussed topics in the space science community in 2025. Despite this friction, Loeb recently shared an encouraging update that NASA may finally be preparing to release the long-awaited high-rise images. According to multiple sources who contacted him, the agency is expected to publish the data within a few days from November 14, 2025. Loeb expressed optimism, calling the news excellent and acknowledging that such a release could dramatically improve humanity's understanding of 3I/Atlas. These new images are expected to surpass the details captured by Hubble in July, offering an unprecedented view of the object's nucleus and its bizarre dust structures. If the spatial resolution is indeed 3 times sharper than Hubble's, scientists could gain insights that were previously impossible to obtain. This includes the exact diameter of the nucleus, the surface properties, and even subtle variations in brightness that could reveal fragmentation, layered composition, or unusual material characteristics. Such information is crucial for determining whether 3I/Atlas fits the expected profile of an interstellar comet or if it possesses properties that challenge existing classifications. Loeb believes that once NASA releases the images, they will become a turning point in the study of interstellar objects. Researchers worldwide will be able to analyze the data independently, cross-examine interpretations, and either confirm or refute ongoing theories about 3I/Atlas. The release could finally bring clarity to the anti-tail mystery, explaining whether the phenomenon arises from viewing geometry, particle size distribution, or an entirely new type of dust behavior. Additionally, the images might shed light on whether 3I/Atlas experienced any fragmentation during its passage near Mars, something astronomers have speculated about but have not been able to conclusively determine. As anticipation builds, the scientific community is preparing for what may be the most revealing look yet at an interstellar visitor. For Loeb, the release of these images represents more than just access to data. It symbolizes the importance of openness, cooperation, and prioritization of scientific discovery over administrative delays. He maintains that the goal should always be to advance human understanding of the cosmos, especially when dealing with objects that originate beyond our solar system. With the imminent release of the high-rise images, researchers hope to finally gain the clarity they need to unravel the mysteries of 3I/Atlas and possibly reshape our broader understanding of interstellar phenomena.